Hi, this is part 2 of a lesson on radical equation solving. In my previous lesson, I solved this radical equation that had radicals with unknowns inside of them. And what I did was I squared both sides of the equation to remove the radicals, gather terms, and in this complicated case, because there were two radicals, even after squaring, I still had a radical. I needed to square yet again in order to get my roots. There were two apparent roots, and I had to check them against my restrictions, and I found out that both of those roots were valid. What I want to do in this lesson is carry on with this example and show it on a graphing calculator to show visually what's going on and how a calculator can help with the solutions and understanding what's happening. So I've entered the equation right here. The left side of the equation, the difference of radicals. The right side of the equation, 2, I've entered as another equation. So y equals 2 is a horizontal line. Y equals 1, the difference of these radicals is going to be an unusual curve with a limited domain. Remember again, we said the domain was greater than or equal to. And what I'm looking for in terms of an answer is that these functions would intersect at a certain place. So because I want values greater than or equal to, I'm going to choose a window that starts just a little bit to the left at 0, and I'm going to go far enough to the right to be sure that I'm seeing everything I need to see. So having done this, 0 and 25, I'm not sure if 25, actually yeah, 25 is going to be good because I knew one of my roots was 20. So let's go 0 to 25 and scale by 5, and I'm going to choose zoom 0, and what zoom 0 does is sets up the range for my given domain. Now, here's my y1. This is the difference of the two radicals. You get an unusual looking curve. Here's y2, the horizontal line. So we can see that the two functions cross here and here, representing the two solutions. And we did have the solutions 4 and 20. Let's confirm that on the calculator. We go to the calculate menu, which is second function calculate, and we want the intersect, option 5. We're going to be asked 3 questions. What the curves are. The first curve is being identified as y1, so I'll push enter. The second curve is y equals 2, I'll push enter. The third question is a guess value. We'd like to know where this is. I can move my cursor toward the left, or I can type a number in. I'm going to type in the number 5. It's a little faster. And sure enough, my intersection is x equals 4 when y equals 2. But I'm really interested in this x value because remember we're trying to solve an equation. Do the same process to find the other intersection. Curve 1 is y1, curve 2 is y2, and my guess, let's move it over to the right edge at 25, and sure enough there's my intersection of x equals 20. Okay, so that's a visual confirmation of what we were doing analytically in this question. Let's go on to one other question, which I have down below here, and I'll just draw it back up. And we are working on another, oops, better not do that. We're working on another radical equation. This one's unusual in that it has a radical in the denominator. What we can do whenever we have denominators in equations is multiply by the LCD. We're allowed to do this in an equation because we're doing it uniformly throughout the equation, maintaining equality. So I will have the first term, that radical on the left, the second term, which is x plus 7 times another x plus 7, and I'll have the third term, which is going to be 4 times the radical divided by the radical, which will cancel. When I have two radicals multiplied, I multiply their inner contents, so I get x squared, 22x, and 7 times 15 is 105. That's all inside of a radical. The square of a square root are inverses that cancel. And what I want to do now is, you'll see that this is similar to other questions I've had before. I have now a radical equation with one radical and some terms that aren't radicals. So I'm going to want to move these terms to the other side, writing negative x and 4 minus 7, which is minus 3, which I could write as negative bracket x plus 3, just gathering those negatives together. The left side I'm not going to do anything with yet. Okay, now I'll take the left and right side. Let me use another color here. and I will square the left side to remove the radical, and I will square the right side as well. So as long as I'm uniformly doing the same thing, both sides of the equation, I maintain equality. Write this one line down here to make it nice and clear for you. Alright, there's the square of the square root, just the contents of the radical. A square of a negative sign is going to be positive. This is a binomial square. Hopefully you remember that a plus b squared, it's the end of class, has that expansion pattern. So I'm going to write x squared plus 6x, which is 2 times x times 3, and 9. Alright, now subtract x squared from both sides of the equation. I'll gather the x's on one side of the equation. 22 minus 6 is 16. I almost wrote 14 there. And 9 minus 105 is negative 96. Divide by 16 and get the root of negative 6. Now, one thing I neglected to do that I should have is talk about restrictions. The restrictions are x plus 15 greater than 0, greater than equals 0, so greater than negative 15, and x plus 7 greater than equals 0, so x greater than equal negative 7, and also because of the denominator, x can't equal negative 7. Now negative 6 is greater, so that's a valid root. And there we go, a couple more of examples on radical equations.